So in the previous video, I went through and talked about how we got the different pieces of our unit circle and put them all together. Previously in the unit, we talked about degree measurements and angle measurements and how we start measuring from an initial side and then rotating counterclockwise through our different quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Then we talked about what radian measurements are and how we can convert back and forth between radians and degrees. We worked with coterminal angles, angles that end up in the same spot but have different angle measurements. So for example, 0 degrees and then 360 degrees would end up in the same spot. Same thing with 0 radians or 2 pi radians. Those are coterminal angles. Reference angles, which are the distance between your angle and the x-axis. So for example, the reference angle for 150 degrees is 30 because that's how far away it is from the closest x-axis. And in the most recent video, I talked about then where these points came from and what they even meant as far as the unit circle goes and what use they have and trigonometry. So we used right triangles to show that the cosine value, the x coordinate of each point is equivalent to the cosine value of that angle. So if I found cosine of 30 degrees, that is in fact the number square root of 3 over 2. Whereas the y-coordinate is found by using the sine value. So sine of 30 degrees is 1/2. And I went through and I showed you where these numbers came from as far as the special right triangles went. But you won't be expected to do that now that we have this full unit circle and we can find sine and cosine as well as just the points themselves very easily from using this unit circle as like a reference sheet. So the outside pieces here are all your tangents as well, which we'll get more in depth with later. But for now, what we're going to do today in this video is practice using our unit circle to find what are called terminal points. So we're going to start with that. All right. So let's talk about what a terminal point officially is first and foremost. So if I zoom in a little bit, suppose t is a real number. Let's mark off a distance t along your unit circle starting at the point 1, 0. And so it'll actually be really helpful if we are looking at our unit circle at the same time as doing this. So I'm going to try to get that up and at them. I just have to shrink this a little bit. Expand this so that way we can work with it at the same time. Okay. So if we're starting at the point 1, 0 and then we mark off a certain distance going counterclockwise, and that way we could arrive at different points around the unit circle, right? So I could arrive at the first point, second point, third point, fourth point, and so on and so forth. The points obtained in this way are called the terminal points. So this is what a terminal point is. And so all of these are terminal points that you would arrive at. We can even find terminal points for what we call, and I'm putting quotation marks around this, too big or too small t values or t's. What we would have to do first with those ones is find, so for example, if I look at negative pi over 2, there are no negatives on my unit circle, so I would say this t is too small, and so what I would have to do first is find a coterminal angle until we're somewhere on our unit circle, and you'll see what I mean when I get to that example, but I just wanted to address it before we even got there. So let's look at our first example. So in this, here we go, in this problem, I'm trying to find the point on my unit circle that is at 3 pi. Now, we might be a little confused by that at first because as of right now, we have 0 pi, we have 1 pi. If you make it all the way around again, this should say 2 pi right here. But 3 pi isn't anywhere on this unit circle. It's too big. And so when we run into one of these situations where your t value is too big or too small, then we find a coterminal angle first. And for coterminal angles, remember with radians, which these are all in radians, you are going to either add or subtract 2 pi depending on whether it's too big or too small. This is too big, so I'm going to do 3 pi minus 2 pi to make it a smaller angle measurement to work with. And then now I can look on my unit circle and say, okay, at pi, do I have just a pi on here? Oh, I certainly do. And so my terminal point is the point that's located at that angle. So my answer for this question would be the terminal point -1, 0. And that would be my final answer. Awesome. All right, negative pi, there are no negative angles on my unit circle, so this is an example where it is too small. So I'm going to probably add 2 pi to it. So I'm going to do negative pi plus 2 pi, which is in fact pi again. Oh, so then I already know the terminal point that's there. All right, negative pi over 2, that one's too small. So I'm going to go ahead and add 2 pi to it. So negative pi over 2 plus 2 pi. Now when I do it with this problem, I run into a little bit of an issue because in my past problems I didn't have any fractions to deal with, and now I do. Secretly, your 2 pi is over 1, and so we need to multiply it to give it a common denominator before I can add these two pieces. So if I give it the denominator that I want, I have to multiply it by 2 on the bottom. So 1 times 2 will give me a 2, just like I have in the first fraction, but I also need to multiply it by 2 on top. So this problem is actually asking me to do negative pi over 2 plus 2 pi times 2 is 4 pi over 2. And so then really negative pi over 2 plus 4 pi over 2 is 3 pi over 2. And I do believe that's on my unit circle somewhere where I can find the terminal point. That's right down here. So my terminal point there would be the point 0, comma, -1. Beautiful. All right, let's start working with some more difficult or less plain angles that end up on just our coordinate or our intercepts. So negative pi over 4, that's too small. So I'm going to go ahead and add 2 pi to that. So I'll do negative pi over 4 plus 2 pi. I need to get common denominators, so that's 2 pi over 1 technically. So I need to give it it needs a denominator of 4, so I'll give it a 4 over 4. So really this problem turns into negative pi over 4 plus, let's see, 2 pi times 4 is 8 pi over 4. 7 pi over 4 would be the coterminal angle. And then so now I'm checking on my unit circle and say, all right, is 7 pi over 4 somewhere on here? There it is. And so then my terminal point would be the point that's at that angle. So my answer to this one would be the point square root of 2 over 2, comma, negative square root of 2 over 2. And so then that would be my answer for that problem, because that's the terminal point that's at 7 pi over 4, and 7 pi over 4 is coterminal with negative pi over 4. All right, let's do this one. 3 pi over 4. Oh, that's actually already just on my unit circle. That's right there. So this is an extra easy problem, because all you have to do is write your terminal point. All right, negative 5 pi over 6. Well, that's too small because it says a negative angle. So I can go ahead and I can rewrite it. Negative 5 pi over 6 plus 2 pi. Oh, need to make sure to get some common denominators. So I need this 2 pi to have a 6 in the denominator. So I need to multiply by 6 on top and bottom. So I have negative 5 pi over 6 plus, let's see, 2 pi times 6 is 12 pi over 6. So really I'm doing negative 5 pi over 6 plus 12 pi over 6 would give me 7 pi over 6. And that is on our unit circle right here. So then its terminal point would be the final answer. negative square root of 3 over 2, comma, negative 1/2. Beautiful. All right, let's do a couple more. So for this problem, 29 pi over 6. Now let's look on here. The highest thing I see over 6 is an 11 pi over 6, so I'm guessing that's way too big. Even if you're not really familiar with your unit circle, like you can figure out what the biggest and smallest numbers are on it. So this is too big, so I'm going to take my 29 pi over 6 and I'm going to subtract 2 pi from it because I need it to be smaller. And I need it, technically right now it has a denominator of 1. I need it to have a denominator of 6, so I'm going to multiply by 6 over 6. So really the new problem I get is 29 pi over 6 minus 2 pi times 6 is 12 pi over 6. And I get 17 pi over 6. Problem with that is that it's still too big. Again, the biggest thing I see on here that's over 6 is an 11. So this is still going to be too big, which means I'm going to have to do it one more time. So all I'm going to do is I'm going to take that 17 pi over 6 and I'm going to subtract another 2 pi from it, or aka 12 pi over 6. So then now I have 5 pi over 6, and I believe I can find 5 pi over 6 on my unit circle. There it is. So then its terminal point would be my final answer. Negative square root of 3 over 2, comma, 1/2. There you go. That is the terminal point. All right, last but not least, 13 pi over 4. Again, the biggest thing I see here over 4 is a 7, so I'm going to assume this is too big. So I'll take my 13 pi over 4 and I'll subtract 2 pi from it. Technically, my 2 pi is over 1 right now, and I need it to have common denominators, so I'm going to multiply by 4 on the bottom, so that way they're both of 4. Whatever I multiply the bottom by, I'll multiply the top by as well. So really, this turns into the problem 13 pi over 4 minus 2 pi times 4 is 8 pi, and then 4 times 1, 4. 13 pi over 4 minus 8 pi over 4 will give me, what's that, 5 pi over 4? And that's on my unit circle right here. So then there's its terminal point. Goodness. Negative square root of 2 over 2, comma, negative square root of 2 over 2. There we go.